Okay, I thought we would practice some nomenclature in this video just a little bit. We're working on ionic compounds, so these are made out of a metal with a non-metal, or metal, for example, like sodium with a polyatomic ion, like carbonate or hydroxide, or all of these are polyatomic ions, or even a polyatomic ion like ammonium could be with a non-metal or another polyatomic ion. So it's all about ionic charges. And remember, the goal in writing an ionic formula is you have to have enough cations and anions so that the overall charge equals 0. We want a net neutral charge. So on my first one, if I put together sodium from this side with chlorine from this side, well, sodium has +1 charge and chlorine has -1, so it really only takes one of these to cancel out one of these in their charge, so one of each would equal 0. So I would just make NaCl for that formula. And then the name is sodium chloride because the cations keep their name the same, sodium, and the anions, the ones that have a negative charge, change their name to IDE. Except, of course, in the case where the negative ion is one that has a polyatomic ion name of its own. If I had done, for example, sodium with, let's say, oxide, sodium is +1. Remember, where I'm finding that is on the periodic table right here. Sodium is +1, and oxide over here -2. Okay, well, it's going to take 2 sodiums to cancel out that oxide. Or you can ask yourself, okay, what's the least common multiple between 1 and 2? Well, that's 2. So I'm going to have a +2 from all the cation charges and a -2 from all the anion charges. All my cations are +2 and all the anions are -2. And it has to equal 0 overall net charge. That's the goal. So I have to multiply sodium by something to get 2 and oxygen by something to get -2. So 1 times what is +2? Well, 2. -2 times what is -2? Well, that's 1. And then this part is what turns into the chemical formula, Na2O. The other method I've shown you at class is to take the sodium +1 and the oxide -2 and just crisscross them. If you take the 2 from the oxide and put it down here, and the 1 from the sodium and put it down here, you get the same result, Na2O. Remember, you can't bring down a negative charge from the oxygen that was -2. You can't bring down the negative number because subscripts down here stand for the number of atoms or ions in the formula, in the molecule or in the compound. And you can't have a negative number of ions or a negative number of atoms. That wouldn't make sense. So if you have any negative charges, you drop it. Let's try another one from the list. Okay, the next one would be sodium ion combining with CO3 -2. Okay, this is going to work kind of like the sodium oxide one did. The sodium, let's do it this way first. That's +1. Again, the least common multiple is 2. So +2 for the cations, -2 for the anions. It has to equal 0 overall. So I'm going to multiply the sodium +1 times 2 to get 2. And I multiply the carbonate -2 times 1 to get -2. And then this part is the chemical formula. So it becomes Na2CO3. And then its name is sodium. What's CO3? Did you memorize that? You're supposed to. Sodium carbonate. And that's how that goes together. Okay, how about, let's do a different one. Let's do ammonium. This one down here, let's put ammonium with let's say SO4. Okay, so we'll come over here and do this one. Well, the ammonium, NH4, has a +1 charge, and sulfate, SO4, is -2. So if I crisscross those down, I can do least common multiple again, or I can just crisscross them. NH4 +1, SO4 -2. The 2 comes down here, and the 1 comes down here. Now this is what makes polyatomic ions a little bit tricky, because polyatomic ions come with subscripts of their own already. So I've got to write this in a way that shows that I need 2 groups of NH4. So make sure that when you're working with polyatomic ions, you don't change the subscripts. Oh, you can't see that, can you? I'm writing you a note. Don't change the subscripts that come with polyatomic ions. Okay, so NH4, that 4 comes with ammonium. That's what ammonium is. So if I need to put a 2 down there, I've got to put ammonium in parentheses and then bring the 2 over, like that. So I need 2 groups of NH4. This makes sure I have 2 N's and 8 H's, not 1 N and 42 hydrogens. So NH42SO4. And what will its name be? Well, NH4 is ammonium, and SO4 is sulfate. Okay, remember when you leave the charges written up at the top, that's like the rough draft work. The final version of that formula would be the NH42, so I'll scribble that out, SO4 without the -2 at the top. Ammonium sulfate. Alright, one more. Let's go down here to the bottom and look at Fe, 3+. Okay, well iron, if you look on the periodic table, iron is not in a column that we labeled up here at the top. It doesn't have a label like the +3s or the -3s or any of those, because it's a transition metal, so it can have more than one possible charge. Iron could be either a +2 or it could be a +3. And where to tell what your choices are is you look on the back of your periodic table down here at the bottom. Formulas and names of common metal ions with more than one ionic charge. And this is how you can tell. Here's iron with a +2. And here's iron with a +3. Okay, so your choices are going to be either iron 2 ion or iron 3 ion, either ferrous or ferric by the old classical names. Now, I didn't have to specify that with like sodium or magnesium because they only come in one formula. They can only be a +1 or a +2. They can't be anything else. But because iron could be one of 2 choices, I'm going to have to specify when I write the formula. So down here, if I combine the iron with the chlorine, the work as far as the formula is the same. A little scratch paper here. So I have Fe +3 with Cl -1. Well, the least common multiple is 3. So I want a +3 with a -3 to cancel out. So I'm going to have to multiply the iron by 1 and the chlorine by 3. And then the formula here is FeCl3. Or the crisscross method. 1 here, 3 here. Remember we dropped the negative signs. FeCl3. And then the name of that thing, that's what I'd put in the box right there. FeCl3. And then the name is iron 3 chloride. Or ferric chloride. So you treat that specially because it's a transition metal. Now I might mention that you have iron 2 down here further down, and here's cobalt, that's also a transition metal, so you'll have to give Roman numerals in their names. Keep in mind that the Roman numeral is the charge on the metal. Okay, the Roman numeral is the charge on the metal. That's how you know what it is. One exception though, look at zinc. You have zinc on your list? Okay, zinc right here is also a transition metal. However, if you'll look real closely in the box right there, it already says +2 because zinc only can be a +2 charge. Cadmium can only be +2 and silver can only be +1. So for these, you don't have to use a Roman numeral. So when you do the problems like with zinc right here, you put zinc with the chlorine up at the top, that's in the top of this column, remember? Then this would just be ZnCl2, and the name is zinc chloride. You don't have to say zinc 2 because that would be redundant because zinc can only be a +2.